Dear student, welcome to my channel. Topic of this video is asymmetric or public key cryptography. Now let us start. It is a foundational concept in modern cryptography that enables secure communication over insecure channel. It uses the pair of keys, a public key which is used for encryption and a private key which is used for decryption. It allows user to securely exchange sensitive information without the need for pre-shared secret key, making it essential tool for secure online transaction, email and digital signature. In symmetric key cryptography, we need n into n-1 by 2 keys where n are users, whereas in asymmetric key we need only if n users are there, we need only n keys. For example, 4 users are there, A, B, C, D. So in symmetric key we need 6 keys, that is 4 into 3 divided by 2, which is equal to 6. Now 6 keys are between A to B, A to C, A to D, B to C, B to D and C to D. But in asymmetric key cryptography we need only 4 keys. Symmetric key cryptography is based on sharing the secrecy, and where asymmetric key cryptography is based on the personal secrecy, that is nothing but the private key. The famous algorithms which are based on asymmetric key crypto system are RSA, Rabin, Elgamal, etc. Asymmetric key cryptography algorithms uses the mathematical properties of number and their operations to create a secure system. So we are using the theorem like Fermat-Euler's theorem implementing the asymmetric key cryptography. Now key management part is very important. Key management refers to the process and technique involved in creating, distributing, storing and updating cryptographic keys in a secure manner. Public key distribution deals with the problem of sharing the public key across the insecure network, because in asymmetric cryptography user has 2 keys, one is private and other is public. Private key is not shared but the public key is shared, but even though public key is shared, it should be shared in a very secure way. Even though the public key is not secret, it must be delivered in a such a way that attacker cannot substitute a fake key. Various methods are used to secure the public key, that is nothing but the trusted, that is it is signed by the trusted certificate authority CA, which ensure that recipient is truly receiving the intended public key and there is no any destruction or modification in the public key. Now I will take a simple example. For example, when we set up an email account with a service like Gmail or Yahoo, the system typically generates the 2 keys, key pair, that is private and public. Private key is nothing but the kept secret and stored securely on our device or within the service, and it is used to decrypt the message or sign the document. And public key, which is signed by the trusted certificate authority, so no one can make the changes in that, to verify its authenticity, and stored on public key or directory. When someone wants to send an encrypted mail to us, they retrieve our public key from the server and use to encrypt the message. This process ensures that even though our public key is available to others, they can be confident that it truly belongs to you and only your private key can decrypt the message. Now we will see the difference between the symmetric key crypto system and asymmetric key crypto system. It is based on sharing the secrecy because same secret key is shared between the 2 users. It is based on the personal secrecy because 2 keys are there, but public key is shared and private key is with the person only. It uses one key both for encryption and decryption. Imagine a single key that can both lock and unlock the same door. This means that both sender and receiver need to have exactly same key for the communication. It uses the 2 key, public key which anyone have and which can be used to encrypt a message, and private key which only owner have and it is used to decrypt the message. The public key is used to encrypt the message and the private key is used to decrypt the message. For example, like mailbox, anyone can drop a letter but only we can open it. Sharing the key can be challenge. You have to find a safe way to send the key to other person. If someone intercepted our message are no longer secure. For example, that's why we are using the Diffie-Hellman key exchange algorithm to securely share the secret key between the 2 users. This is much safer because we never share the private key. only the public key is shared, which means even if someone intercepts the public key, they can't decrypt our message. It is faster, it is slower, and generally for encrypting the large messages we use a symmetric encryption, and initially we use asymmetric key encryption to share the keys, and after that we go with the symmetric key cryptography, because for the large messages this method is efficient. And when we want to go for authentication, digital signature or secret key exchange, which is required in symmetric key cryptography, we are using the asymmetric key crypto system. Now this is the general structure of the asymmetric key crypto system. For example, when Alice want to send a message to Bob, then the process initiated at the place, that is at the receiver side. So using some parameter, it shares the public parameter to the Alice. Using that public parameters, it encrypts the message, and encrypted message is sent over in secure channel, and this message can be decrypted only with the receiver's private key, otherwise the message cannot be decrypted. So this is the general idea of asymmetric key cryptography. So for ciphertext, we are using the public key, that is encryption is done with the public key, and this is the plain text. So decryption, to get the original plain text at the receiver, we are using the private key. So asymmetric key cryptography is based on the trapdoor one-way function. Now we'll see what is meant by trapdoor one-way function. Trapdoor one-way function, that is TOWF, it is a cryptography function that is easy to compute. For example, if input x is given, it is very easy to calculate the f of x, but hard to invert. That is, if f of x is given, it is very hard to compute the x without any spatial knowledge, and that spatial knowledge is called trapdoor. So it is computationally infeasible to determine x from given f of x without some spatial knowledge. Trapdoor for efficient inversion. With access to specific secret, it becomes efficient to compute x from f of x. For example, we will see the RSA function, trapdoor function. So f of x is equal to x raised to e mod n. This function we are using in RSA. Now for encryption, we are using c equal to m raised to e mod n, where e and n are the public parameters, and where e is nothing but the public key and of the receiver, and which is used to encrypt the message. Now at the sender side, it uses the receiver public key and encrypt the message, and at the receiver side decryption takes place, and decryption is nothing but the receiver's private key, that is nothing but d. This is ciphertext. So formula is m equal to c raised to d mod n, where d is private and n are public. Now in RSA, this d and e, they are multiplicative inverse of each other, that is e into d inverse is equal to congruent to 1 mod phi of n. Now here, if we want to reverse, for example, this is a forward operation which is very easy, but this is a reverse operation, and in this operation we should know d, then only we can decrypt the message. So for that, if we try to guess the d, we need to calculate phi of n, and if n is very large, it is very difficult to calculate the phi of n. That is nothing but what? Factoring. It is computationally infeasible with current methods. So nowadays we are taking n is a very large prime number, so it is very difficult to calculate the phi of n of very large number. But if we know the p and q, because n is nothing but the multiplication of p and q, but if we know the p and q, where n is equal to p into q, then phi of n is very easy to calculate, because p and q are nothing but the prime number and their multiplication is n. So if we know the p and q, we can easily calculate the phi of n, and if we know the phi of n and we know e, because e is publicly available, d can be easily calculated. So that is nothing but the trapdoor function is nothing but the factoring of the large number, but factoring of the large number is not possible in a polynomial time. So without the private key, that is trapdoor is nothing but the prime factors of p and q, inverting f of x, that is finding the d, is very difficult. Now we will see the discrete logarithm problem. For example, here f of x is equal to x raised to d mod n, where n is the prime number and d is nothing but the x is nothing but the generator of that particular group, that is of generator of the n. So x has a capability that it will generate all the numbers from 1 to n minus 1. Now here d is the private key of the receiver. It is very easy to calculate the f of x in this x and n are public and d is private. Therefore f of x, x and n are public, but if we want to guess a d from the f of x, it is very difficult, because to guess the d we need to calculate x raised to d congruent to f of x mod of n. Now I will explain with the example. So in this example, n is public, x is public, d is private. So if we know the d, we can easily calculate the f of x is equal to x raised to d mod n. So forward side is very easy. But if we know the f of x, x and n, and we want to guess for the private key, which is the secret d, then at that time this problem is very difficult when our n is very large. Now we'll see the problem. For example, f of x is equal to x raised to d mod n. Now here we have, for example, we have f of x is given, private key d which we want to guess, x is 5, that is nothing but the generator for p equal to 17, and d is private key, and we want to guess the private key, and these three values are given, f of x, x and n. Forward way, f of x is very easy to calculate because we know the d, but in reverse way it is very difficult to guess d from the f of x, x and d. Now for example, the p is 17, x is 5, f of x is 12. So for that different values of d are possible, 9, 25, 41, 57. Infinite possibilities are there where n is very large. So it is very difficult what is the perfect value of d. So that is nothing but discrete logarithm problem. So application of trapdoor one function, it is used in public key cryptography, it is used in key exchange protocol, and it is used in digital signature. So these are nothing but the references for the video. Thank you.